I want everyone in the audience to imagine that you are the pilot of a small airplane. Everyone has seen movies with Tom Cruise where he's in an epic getaway, but you are the pilot. You begin to take off down the runway. You get 100 feet above the ground, and suddenly your seat slides back. You pull up on the controls, your plane starts to stall, and you crash straight into the ground. This is the unfortunate reality for dozens of pilots over the last few decades.
Hello, everyone. I am Tanner Hornung.
And I'm Jonah Johnson.
And we are both seniors in the mechanical engineering program here at UW-Stout. And we both strive to make great innovations in the aerospace industry. We are working with this project with our faculty advisor, Abhi Verma, as well as a local aviation company located right here in Menominee called Gibson Aviation. Gibson introduced us to our research problem, as well as donated supplies to help get us started on this project.
The specific plane we are working with is the Cessna 172, but our current scope impacts 18 different models of Cessna aircrafts. The problem we are facing is with the seat track's current design. Wear and tear on the track can cause the pilot seat to slide back during takeoff.
Currently, the Federal Aviation Association, or FAA, has a Band-Aid solution set in place, where the seat tracks have to be inspected every 100 flight hours. This costs several thousands of dollars in parts and labor. Not only that, but improper care for these tracks have taken several lives already. This is no solution to the problem.
The goal of our research is to design and test a new track that will prevent the pilot seat from sliding back during takeoff. Using 3D modeling software, we have modeled the track and the pilot seat and have simulated the forces acting on the system. We have also conducted research to identify the material of the current track, and we are researching new materials that can be a suitable replacement.
The next step in our project is to test our new design. This will require access to raw materials that we can eventually manufacture into our final design. We will then need to test this new design and make sure that it resolves all of the current seat track failures. Then we will get approval from the FAA to implement our new track design in planes all over the country.
Everyone in the audience today can be a part of the solution. With your support, we can finish our research, conduct testing, and prove that our new design will solve the problem.
With countless lives taken over the past few decades, we can finally put this issue to rest, right here in Menominee, Wisconsin. And finally, we can bring back confidence to pilots all over the country. Thank you.
Thank you.
Are there approvals for the research study, given the sort of life and death nature of putting this into a plane and getting so many hours of testing? How does that work?
So currently, there's the solution they have every 100 flight hours, so it's called an AD that they have. So that's the only thing that's like preventing this from being a greater problem. The research we're doing isn't funded or kind of like monitored by the FAA. This is for an independent study. Right now, we're not doing any sort of testing. We're right to that stage, so we have everything set right. And now we're just like we have numbers, we have results from a computer. We haven't actually tested them in real life yet.
Right. So I guess the next step is to have our physical model, run the tests on that model, which proves that it should work in theory, and then actually get the materials to machine a new track design and implement it with the seat that we have. Obviously, if we get more funding, we'd be able to get a better seat for testing. And this thing's pretty, yeah.
You're ready.
And then the next step would be taking that idea to the FAA, and we would fill out a form online and basically get in contact with them to say, hey, we'd like to try this out. Here's the research that we've done. Here's the tests that we have that prove with this factor of safety that we found that it'll work. And then they'll go through and we'll work with them to actually test it, like you said, like several hours of takeoffs and whatnot, and whatever they use in their labs to test seat tracks and such.
Mm-hmm.
I have a question.
Yep.
So is the issue mainly with the type of material that's being used or the structure of the way it's situated right now?
It is a little bit of both. we concluded with our results that the material is not, I would say, strong enough. If you look closely, the holes are very elongated. The pin that goes in them is supposed to be much smaller. But over the years, the wear and tear has pushed these holes farther apart, and then there's cracks on the side. So that's what causes the seat to come out of the hole and then slide back. So we concluded that the material, its peak strength is not great enough for the strength that's needed. So the material is a problem. But there's also a structure too. There's only one location on this seat holding the seat to the track. All the other legs are free to slide back and forth. So there's all that stress on one location, which is not good.
Right. And just for reference, this plane was made in 1956. And it's still widely used today. The Cessnas, they've lasted, they've stood the test of time. It just so happens that this was one of the major failures over the last, several decades.